Alright, scientific notation. Now, scientific notation you have seen both in science class and in math class. Now let's review. Scientific notation is a short way to write very large numbers or very small numbers. So it makes it easier than writing all those zeros and whatnot. Standard form is writing a number how we normally see it, with all of the zeros added in, versus scientific notation, we get rid of a lot of zeros. So, now some key hints when writing in scientific notation. If the number is greater than 1, meaning the number you're writing in scientific notation, if it's greater than 1, then the exponent will be positive. So think of those large numbers are going to have positive exponents. When changing into scientific notation, if the number is less than 1, then the exponent will be negative. So think of small numbers, you're going to have a negative numbers, less than 1. Okay? So when changing into scientific notation, you need to move the decimal to where there is only one counting number. And when I'm talking about counting numbers, I'm talking about numbers 1 through 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It can be 1 and it can be 9, but nothing else above that. That needs to be in front of the decimal. Alright, so let's look at some practice problems. So the first part we're going to do is change these numbers into scientific notation. So this first one, 75 million. Now this is a very large number, so I need to know is definitely going to have a positive exponent. So if my decimal starts back here at the end of the number, I need to move it so that I only have one counting number in front of it. So I need to move it all the way till it's right after that 7. So I move it 1, 2, 3, 4, 5, 6, 7 places. So I'm going to do 7.5. And since there's only zeros after that 5, I'm going to drop them off. Then I do times 10, and I moved it 7 places, so I do 7 times 10 to the 7th power. Remember, it's positive because it's a very large number. Now, let's do this one. This one's a very teeny tiny number. So what I need to do is move this decimal so that I have one counting number in front of it, which is right there. So I'm moving this. I'm going to move it 1, 2, 3, 4, 5, 6, 7 places as well. But this time, instead of making it a positive exponent, it's got to be a negative exponent since it's really a small number. So I'm going to do 5.08. And notice I'm dropping all of those zeros in front, but I'm making sure I keep the back part of my decimal. Times 10, and remember it's a negative exponent, it's a very small number. Now let's change them from scientific notation into standard form. Now remember, if it's positive exponent, that means it's a big number. That means I want to add those zeros onto the end of the number. So I'm going to take 3.79, okay, and I need to add in some zeros. So if I move it 1, 2 places already, I still have 5 more places. So I'm going to add 5 more zeros. So 1, 2, 3, 4, 5. So I need to go 1, so 1, 2 already, 3, 4, 5, 6, 7. So my answer is 3, 7, 9. Add your zeros. So 37,900,000 is going to be my answer. Notice I didn't leave my decimal there. I got rid of it because it's all the way back here. Okay? So you need to make sure for your answer you write it out just like that and not leave it like that. So 1 times 10 to the negative 4th. It's a negative number. That means I need to add zeros onto the front part of my number. So I'm going to start with 1 here. I'm going to add some zeros. Okay, if my decimal was here, I go 4 places. 1, 2, 3, 4. And it's going to end there. So my answer is 0.1231. Those aren't 6s, they're zeros. And then there's my answer. Notice I rewrote it from here to here to show my actual answer. Alright, now multiplying with scientific notation. Yeah, you can shove it in the calculator, multiply it out and do it, but there's actually a little quicker way. So what you need to do when multiplying scientific notation, so like this one, 5.1 times 10 to the 7th times 2 times 10 to the 2nd. What you're going to do is kind of rearrange it. You're going to stick these two numbers and you're going to multiply those. So 5.1 times 2. Then you're going to do 10 to the 7th and 10 to the 2nd. Remember, our multiplying binomials or exponents, you're going to apply that here. So I'm going to have 10 to the 7th times 10 to the 2nd. Now, 5.1 times 2 is 10.2. Okay, here, same base, add exponent. 7 plus 2 is 9. Now I get 10.2 times 10 to the 9th. That is not in scientific notation because I have two counting numbers in front of my decimal. So I need to move my decimal once to put it between the 1 and the 0 going left. Now, since this number is bigger than 1, I'm going to add to my exponent however many spaces I move. So I move one spot, so I'm adding 1. So instead of it's 9, it becomes 10. So I have 1.02 times 10 to the 10th power. Now, my next example, I have 2.3 times 10 to the 4th times 4.5 times 10 to the negative 5th. Okay, my 2.3 and 4.5 multiply them together. Then my 10 to the 4th and 10 to the negative 5th, multiply them together. When I multiply these two numbers together, I get 10.35. Add my exponents, I get 10 to the negative 1st. Again, I need to move my decimal one place. Since it's larger than 1, I add the number of spaces. I move it once, so I'm adding 1 to my exponent. So negative 1 plus a positive 1 is actually 0. So 1.035 times 10 to the 0 is my scientific notation. Now, 10 to the 0 we all know is 1. So really, my answer is 1.035. Now, let's look at dividing scientific notation. This is the last thing. So with this, I'm doing the same thing with multiplying. As in, I'm making sure these two numbers, instead of multiplying, I divide them. And then I group my exponents with like bases. So 7.2 divided by 4 actually is 1.8. Then you do negative 5 minus a negative 3, which I have here. And that is going to be keep, change, change. So negative 5 plus a positive 3, which gives me a negative 2. So my answer is 1.8 times 10 to the negative 2nd. One last one. 1.2 times 10 to the 4th divided by 3 times 10 to the 8th. Okay, do 1.2 divided by 3, and then 10 to the 4th divided by 10 to the 8th. Subtract these two exponents. Now 1.2 divided by 3 is 0.4, and then 4 minus 8. I don't know why I put negative 4 minus 8. I made a mistake. Little mistake. We'll fix that. Alright, so 4 minus 8 is going to give me a negative 4. Alright, now this is 0.4, which means it doesn't have a counting number in front of it. So I need to take it and move it one space in the back. Since it's less than 1, I need to subtract 1 and move it one spot from my exponent. So negative 4 minus 1 is going to be to the negative 5th. So my answer is 4 times 10 to the negative 5th.